Hello. Welcome back to Elements of Civil Engineering and Mechanics class. This is our second class. In the previous class, so we discussed about elements of civil engineering, but in this class, we are going to talk about Introduction to Engineering Mechanics. So what is engineering mechanics? Engineering mechanics is a branch of science which deals with the conditions under which a body is at rest or in motion. So mechanics can be divided into two parts. One is statics and the other is dynamics. So there is one more branch called fluid mechanics, which I am not going to cover here. So I am only going to concentrate on statics and dynamics. So statics deals with the bodies under rest. So that is body at rest. And dynamics deals with the bodies under or at motion. So dynamics can be further divided into kinematics and kinetics. Kinematics and kinetics. So what is kinematics? It deals with the bodies under motion, and also it deals with only the geometry of the motion without taking into consideration the agents which are causing the motion of the body. So here it takes into account the agents. So what are the agents? Basically the force is the agent. So that is going to, that is the agent which alters the body whether it is at rest or in motion. So coming to the definition of different bodies, let us discuss about the rigid body. So let us consider a body, and the same body here, the same body, little bit oriented. So if I consider 2 points A and B, say if D is the distance between those 2 points, so let me subject this body to different forces all over, okay, say F1, F2, F3, F4, F5, F6. So the same point AB, distance D. See, here we have the body. A rigid body is one which does not change its shape or any form under the influence of external forces. In other words, if we take any 2 points on the body, say A and B, at a distance of D, then if you subject the body to external forces, the relative positions of those 2 points remain the same. Relative positions in the sense, say for example, due to the external forces, this body has little bit rotated. As far as the positions of these 2 points, that is the position of A with respect to B and the position of B with respect to A remains the same. That is, the distance d remains constant. That is the definition of rigid body. Let me write down the rigid body definition so that you can write down the notes. It is a body which can retain its original shape and size when subjected to external forces. So please write down this. Body of which occupies no space. This is a particle. Next, continuum. So what is continuum? See, in continuum what we do is, if we take a body, we are going to assume the body consisting of infinite number of small molecules which are packed in such a way that there is continuity. That means there is no space in between. So this is purely theoretical. So let me write down the definition of continuum. So the concept of continuum is purely theoretical. A continuum is made up of infinite number of molecules, and packed in such a way that there is no space in between. There is no space in between. So next, point force. A point force is said to be acting at a point which occupies no space. So that is point force. Force it is an agent which alters the state of a body under equilibrium or in motion So force has four characters or four characteristics. So a force has four characteristics, that is magnitude, direction, line of action and point of application. So what is magnitude? So magnitude is the length, it is the length of the force vector. So the next one is line of action. Direction, and the last one is point of application. Point of application. So as I said, so magnitude is the length of the force vector. So this is the magnitude of the force. And what is line of action? Line of action in this case, if you look at the beam, so this is the beam, line of action is vertical. So here from figure, the line of action is vertical and the direction is downwards. And the point of application, that is the point at which the force is acting, is at A. Therefore, point A is the point of application. Point A is the point of application. I hope this is clear. So these are all the definitions. So it is force, it is an agent which alters its state of rest or motion of a body. So force has 4 characteristics. One is magnitude. So if we write force is a vector, so we are going to write that force to certain scale depending on the magnitude, and whatever the length of the force vector represents the magnitude. And another character is line of action. Here the line of action is vertical. So in this case, from this figure, if we take this figure, this line of action is horizontal, and the direction is, so if we take this force, the direction is downwards. If we take this force, it is acting rightwards. Okay, and the point of application, where exactly the force is acting, the point of application in this case, it is point A. Next, coming to the classification of force system. If I take a system of forces, so it may be coplanar or non-coplanar. Those things can be further divided into, so I am going to club this because further classification of both coplanar and non-coplanar forces is the same. So it is concurrent, and non-concurrent. So it is concurrent means acting at a point, it is diverging forces, converging forces, and both converging and diverging forces. So when it comes to non-concurrent force system, parallel force system and non-parallel force system. Okay, so under parallel force system we have like forces, unlike forces. Unlike forces. I am going to explain what is the meaning of each one. So you know the definition of force, I already explained. So coplanar. So coplanar, if a system of forces is acting on a single plane, say for example, this board is a single plane. If we have a system of forces like this, okay, it is a coplanar force system. just to make you understand better, so I am going to consider two planes. I am writing 3D figure here. Okay. So if I consider a system of forces is nothing but a group of forces. So F1, F2, F3 and F4, F5, F6, F7. So these forces, that is this system of forces is acting on this plane and this system of forces is acting on this plane. So if I take this system of forces F1, F2 and F3, because they are acting on a single plane, they are called coplanar force system. Similarly, here these forces are acting on a different plane. That is F4, F5, F6 and F7 are acting on a different plane. So these forces also constitute a coplanar force system. If you combine all these forces, F1 to F7, they are non-coplanar force system because a set of forces are acting on this plane and another set of forces is acting on this plane. So these are coplanar, combined together it is non-coplanar. Next, coming to this, again coplanar and non-coplanar have the same classification. So in coplanar we are going to get, that is 2D forces. This is non-coplanar, that is 3D forces, because the forces act in 3 dimensions. So when you go further classification for coplanar and non-coplanar, they are the same. So that is concurrent force system and non-concurrent force system. So what is concurrent force system? If you take a system of forces, if the forces are acting at a single point, these forces, these 3 forces, F1, say F2 and F3, this system is called the coplanar concurrent force system. If there is another force acting perpendicular to the board or inclined to the board, then the force system becomes non-coplanar, then it is called non-coplanar concurrent force system. I hope this is clear. And under concurrent force system, again we have 3 types: diverging, converging and both converging and diverging force system. So what is converging force system? So converging force system is, if you take these forces, so all the forces are acting towards the point. That means they are converging at a single point. So this is called convergent force system. Next, if I take a set of forces which are acting away from the point, then these are convergent force system. Then coming to this, both converging and diverging. So again, system of forces, some forces are acting away from the point, some forces are acting towards the point. This is both converging and diverging. This system is called coplanar concurrent, both converging and diverging forces. Say for example, if I take another force which is perpendicular to the board, if I take another force inclined to the board, then it becomes non-coplanar force system, then it becomes non-coplanar, concurrent, both divergent and convergent force system. I hope this is clear. Next, coming to non-concurrent force system. say for example, if I take this, so these forces F1, F2 and F3 are acting in certain direction. If you extend the line of action of the force like this, there is no common meeting point. All three forces are not meeting at a point. So this is called non-concurrent force system. So again, these forces are also non-concurrent force system, because if you take that system of forces, they are not meeting at a single point. That is, if you extend the lines of action of the forces, they are not meeting at one point. Next, under non-concurrent force system, parallel force system and non-parallel force system. What is parallel force system? So if I take a system of forces like this, okay. So if I take a system of forces like this, if I take a system of forces like this, okay, these are coplanar parallel force system. Similarly, these two forces are again coplanar parallel force system. Similarly, these things. So of course they are acting in different directions, but those forces are parallel to each other. So if I take another force here, somewhere in the space which is parallel to these forces, one or two forces parallel to these forces, then it is non-coplanar, non-concurrent, parallel force system. Okay. These are the like forces, like parallel forces. Then what is unlike parallel forces? Again, if I take these forces, three forces, if one of the forces are more than one, are acting in different directions, these two are acting towards right, these two are acting towards left, then it is coplanar, non-concurrent, parallel, unlike forces. Similarly here, so if I draw another force like this, they are not acting in the same direction. Of course they are parallel, but they are not acting in the same direction. So it is called coplanar, non-concurrent, parallel, unlike forces. I hope this is clear. Similarly, if I take another force in space, 1 or 2, 3, any number of forces which are parallel to this, then it becomes non-coplanar, non-concurrent, parallel, unlike force system. I hope this is clear to you. So there is a special case called collinear forces. So what are collinear forces? If a system of forces are acting in the same direction, along the same line, it is called collinear force system. If you look here, so these forces are acting in the same direction. Okay. And if I take another force, this may be acting this way. So again, all these forces combined together form a coplanar, collinear force system. Next, principle of transmissibility. See, what is principle of transmissibility? So, in mechanics, one of the assumptions we make is the body is rigid. Okay, with that in mind, so what principle of transmissibility says is the conditions of equilibrium or motion of a rigid body does not change if a force is acting on a body at certain point is replaced by the same force, that is the force of the same magnitude, and putting that in another point, not replacing, sorry. So, moving that force to another point, the condition does not change as long as the directions of these two forces remain the same, or directions are nothing but the lines of action, the line of action of the forces remains the same. That is the principle of transmissibility. So, it states that the principle of physical independence of forces states that the action of a force on a rigid body is not affected by action of any other force on the same body. So here if I take this, again same body, okay. So the body is subjected to the force F1 that results in acceleration A1. Similarly, the same body is subjected to F2 that results in acceleration 2. So these two are independent. That is, this force and this force are independent. Okay, and of course, to get the combined effect, we can add those two numbers algebraically. And we are going to get the acceleration, and that should also be added algebraically to get the combined acceleration. I hope this is clear. So, thank you.